Dr. Mike Jones is the co-director of the Qualitative Fishery Center at Michigan State University, and he's here to tell us a little bit about his experience with using fishery models and how we use them to inform difficult management decisions in Michigan.
Well, good morning, everyone, and thank you for having me to this conference. Lauren asked me to speak to you about work that we do at the Quantitative Fisheries Center at Michigan State University on using computer models to help inform decisions about fishery management in Michigan and elsewhere in the Great Lakes. And what I'm going to do is this is not going to be some dry lecture on the details of simulation models. What I'm going to do is to tell you a story about one of the long-term projects that we've been involved in that illustrates how models are used in a process to do what this title says, help inform difficult management decisions. And I'm going to emphasize the first thing I wanted to say is that one of the things that we have learned over the years in working in this area of building models to apply to fisheries management is that perhaps the most important thing about a good decision-making process is not so much the technical quality of the modeling, but the way in which you do it vis-a-vis your interaction with those stakeholders and decision makers who are going to be affected by the process. And my talk today is going to help to illustrate that point. I'm going to talk to you about walleye, and I'm going to talk to you about walleye in Lake Erie. Walleye, as you know, is probably one of the most important, economically important native fishes in the Great Lakes. And it's extraordinarily important in Lake Erie, where it is both a large sport fishery and an equally large commercial fishery. So the sport fishery for walleye in Lake Erie is mostly in the U.S. waters. About 90% of the harvest is taken in U.S. waters. And over 3 million angler hours are spent trying to catch walleye on Lake Erie in a typical year. The commercial fishery for walleye is exclusively in Canadian waters. There are no licensed commercial walleye fishermen in U.S. waters of Lake Erie. And the commercial fishery harvests about 3.5 million fish, or about 5 million pounds, I think, on average. So it's a very large, probably one of the largest commercial fisheries in freshwater ecosystems. And I mentioned that it's managed as an individual transferable quota system, which if you're interested in what that is, I can talk about it later, but it's not really that relevant to the story that I'm telling you today. To underscore just how important walleye is to the stakeholders and citizens around Lake Erie, their minor league hockey team is named after the fish. And perhaps more significantly, a lot of Americans are gathered either on television or in person in Times Square at midnight on December 31st. The citizens of Port Clinton, Ohio, gather here to watch, rather than the ball drop, they watch the walleye drop. This strikes me as a pretty extraordinary devotion to a fish. So let's have a little bit of a look at the walleye situation in Lake Erie. This graph is showing you the time series or trends in what we call the recruitment of walleye, the abundance of the fish that are entering the fishery at age 2 from 1977 all the way up to 2019. And I show you this graph because I want to emphasize something that's evident from this, is that there are occasional years in which we see an awful lot of fish entering the fishery. 1984, 1988, 2005 are examples in this graph. And then many, many other years where the recruitment is low to mediocre. And that results in this type of pattern in this fishery and many other fisheries, that the population of walleye, I've listed them as, I call them adults here, the 4-year-old and older walleye that are the primary object of the fishery. The availability of those fish is overwhelmingly influenced by these recruitment events. And I make this point to emphasize that the performance of this fishery and many others is driven more by these natural phenomena of recruitment than it is by the actual fishing practices that are going on. And that's certainly the case here. Certainly the trends in adult walleye are largely explained by these trends in recruitment. Now, these two graphs that I just showed you are sort of an illustration of part of what we do at the Quantitative Fisheries Center. So we do basically two things. We figure out how to count fish, and counting fish is no small task. Fish are, they don't stay in one place, and they're very hard to see because they're underwater. And so the problem of actually determining the supply of fish in a lake or ocean or bay or whatever, a river, is really a remarkably challenging problem. And the whole enterprise of figuring out how to do that is referred to as stock assessment. So one of the sort of foundations of the work that we do at the QFC is developing and refining techniques for both being able to count fish and also to be able to estimate how accurately we're counting fish, so how uncertain we are about how many fish are present. And that sort of helps us to look back in time and say, this is what the fish populations have looked like over the last years, just like those two graphs that I showed you illustrated what walleye populations look like over the last 40 odd years. And then the second thing we do is we forecast what will happen to fish in the future. So this is the piece that I'm focused on today, is the idea of using models, simulation models, to ask questions about, given what we know about the fish population in a particular lake or ocean or whatever, and given possible strategies that we would use to manage that population in the future, what would we expect would happen to the population going forward? With the idea being that we want to find a management strategy that is sustainable. It is likely to ensure that there will still be plenty of fish to be harvested in the future. So in the case of walleye in Lake Erie, about now 20 years ago, the managers around Lake Erie, there are 4 states and 1 province that have jurisdiction over the walleye fishery in Lake Erie, approached us at the QFC and said, we'd like you to help us to develop a harvest policy, a set of rules for how we set quotas that is informed by this sort of work, by stock assessment and simulation modeling. And so we spent a period of time working with the biologists and the managers on Lake Erie, and we ended up developing what this is called a harvest policy for Lake Erie. This one is referred to as the sliding F policy. And the idea of this is that on the x-axis, we're saying, what do we think the current abundance of walleye is in the lake? And then on the y-axis, we're saying, how much fishing are we going to be allowing? And so the basic notion is that when there's lots of fish in the lake, over 40 million in this case, fishing can be allowed at a relatively high level. But if the abundance starts to drop down, we're going to kind of ratchet back on fishing until to allow the population to recover. So this was a policy that we did a lot of analysis to examine its performance using these models to forecast in the future. So it was what we would call intensively simulation tested. But what this model wasn't was a model that was stakeholder tested. So we built this model basically behind closed doors in our research lab, if you will, at Michigan State, working with biologists and managers that work for the management agencies. This policy was put in place around 2004, 2005, and it was not met with a lot of enthusiasm from the stakeholders. So here's a couple of excerpts from publications at the time, the media at the time. On both the Canadian side, Peter Meisenheimer represented the Ontario commercial fishery, and on the US side. Basically, the stakeholders were not happy. The stakeholders on the US side were claiming that the policy was allowing too many fish to be harvested by the commercial fishers. Stakeholders on the Canadian side, primarily commercial fishing industry representatives, felt that the policy was too restrictive. And the bottom line is that they were disenfranchised from the process, the technical process that was used to inform this decision. And this was a hard lesson to learn, I guess, for the fishery managers around the lake. But they did learn that lesson. And in 2009, they came back to the QFC and they said, we'd like to revisit this analysis that you did, but this time we'd like to do it in an engaged and inclusive manner. And so we did. And in 2010, the Lake Erie Committee, the representatives of the 5 management agencies, created a group called LEPMAG, the Lake Erie Perked Management Advisory Committee or Advisory Group. This is a picture of the membership of that group about 1.5 years, 2 years into the process. And so the people that you're seeing there are walleye charter fishermen, biologists from management agencies, representatives from the Ontario Commercial Fish Producers Association. So a mix of commercial and recreational stakeholders and managers and biologists. The group had the QFC were the so-called facilitator modelers. Our role was to essentially guide the process and do the technical analysis, the modeling and stock assessment. There are fishery managers and these other stakeholders. And our task as a group was to step back from this fishery and develop a harvest policy that we could ideally all agree upon was a fair and equitable policy for walleye in Lake Erie. So early on in the process, we developed a vision statement that said Lake Erie perked fisheries will be transparently managed using sound science and partnerships to achieve stable and sustainable harvests from shared stocks, providing broad and equitable benefits for all jurisdictions. So everybody on LEPMAG was able to get behind this vision statement and was willing to work together after we had begun to listen to each other's point of view. Over the course of 4 years, we met 12 times. We developed a set of rules of engagement for the process as to, who could attend the meetings and whether we would decide things by vote or only by consensus and so on. We invested some time in what we call framing the problem using a method that is referred to as structured decision-making to identify what management alternatives we would like to consider, harvest policies, and what our objectives are for the fishery, the objectives of the various stakeholders. And then we spent a lot of time discussing and thinking about how to construct models that would represent our understanding of walleye dynamics and the fishery. And halfway through this process, in order to ensure that we weren't it wasn't too incestuous a process, we invited some outside experts to come and give us a sort of a report card on our analysis. So what our task in a nutshell was to try to find a harvest policy that seemed to provide the best shared benefits amongst the various stakeholders. And so what we did is we looked at a series of harvest rules, not unlike the one that I showed you before, that sliding F policy, where in every case, the thing that you're measuring is the status of the stock. In this case, it's the biomass relative to what the theory would suggest the maximum biomass would be. And then the fishing intensity or fishing mortality that you're going to allow. And as I said before, the idea is that if there's lots of fish around, you can harvest at some high level. And if there are fewer fish around, if the population is in decline, then we ratchet back on the fishing to a low level. And so the policy is defined essentially by what we call 2 reference points: a limit reference point, which is this biomass of the fishery where we start to be a bit more conservative, and the target reference point, which is the fishing rate to a level where we can fish at this target level. And our model analysis basically took what we understood about walleye survival rates and fishing rates and so on and so forth, and asked how will different target reference points and limit reference points perform in terms of achieving the expected benefits that fishers are looking for from their fishery. So I'm going to show you a couple of graphs now that are really busy, and I want to try to just go through them quickly and just emphasize the key points that I want to make for the purposes of this presentation. So the first one is a graph that shows basically what this is showing is the outcome for a wide variety of different candidate or possible harvest policies, varying the target reference point here, varying the limit reference point between these three panels. And then this is also a metric about how much risk you're willing to tolerate. And I probably won't spend much time talking about that. What's being plotted here is the outcome, the model forecasted outcome for the commercial fishery, the pounds, number of pounds, millions of pounds of walleye that you would expect to harvest on average over the long run, depending on which policy you chose. And what I want you to see here is that when you go from a relatively low target of 40% up to a high target of 80%, it makes quite a big difference to the average harvest that the commercial fishery is going to enjoy. This should not be surprising. Allowing more fishing, a higher target is going to allow you to catch more fish as long as you don't overfish. The other thing I want you to notice is that while the variation in these bars from 40% to 80% is quite large, there's very little difference between the white ones and the gray ones and the dark ones. There's also not very much difference between this panel here and this panel here. There's a little bit of a difference over here, but basically I'm telling you this because what this is pointing out is that the variable in our harvest policy that makes the biggest difference to the outcome is this F target. So that's what we're going to focus on as I go forward. So this graph is just showing the results of our models for a different performance metric. This is for anglers. So this is the number of walleye that are harvested on average per year, again, depending on which policy is being adopted. And what you see here, not surprisingly, is that as you increase the the target fishing rate for the commercial fishery, the number of walleye that the anglers are able to harvest declines somewhat. You should notice that it's not declining quite as steeply as the commercial harvest was increasing. But other than that, the pattern is pretty similar here as it was for the commercial harvest. And this turned out to be really important in the process because when we started to look at trade-offs, because this type of problem and many fishery management problems are about trade-offs or about figuring out a sweet spot where people who have stakeholders that have conflicting objectives can somehow find some middle ground that is acceptable to all. And so this analysis showed us that on this graph on the x-axis, I'm showing you the probability or the risk that commercial yield would fall below 4 million pounds, which was what the commercial industry said was their level of harvest that they needed to sustain their facilities, their production, processing facilities, and so on. And on the y-axis, we have the probability of the angler catch per hour being below 0.4, which basically means about one fish every 2.5 hours. And that was what walleye charter fishermen said was a catch rate that they needed to be able to be competitive to attract clients. And what you're seeing here is these are the values for these two probabilities depending on what target fishing rate we use. And the important thing to notice is that as you go from 40 to 50 to 60, there's a very large drop in the risk, the probability of a bad outcome for the commercial fishery, and really a very modest increase in the risk for the recreational fishery. When you get to higher target fishing rates, the risk for the recreational fishery starts to increase more rapidly relative to the loss of risk for the commercial fishery. So seeing this result as we worked through this process led the entirety of the LEPMAG group to land on this point right here, 60%, a target reference point of 60% as being a reasonable compromise between the objectives of the commercial and the recreational fishery. So in January of 2014, the working group recommended that. The Lake Erie Committee adopted that recommendation and has used that harvest policy from that point forward to the present. One of the consequences of that is that the Lake Erie walleye fishery, commercial fishery, is now MSC certified and Marine Stewardship Council certified, which was something they were working for. And the main thing that they needed that they didn't have was a harvest policy that was informed by a rigorous model or simulation analysis. But perhaps the most significant consequence of all of this is that those media reports that I showed you several slides ago, which indicated that some stakeholders were pretty unhappy with management, I could have spent a lot more time on that. The conflict, as some of you may be well aware, was enormous on Lake Erie between commercial and recreational fishermen. That conflict has virtually disappeared. I'm not going to suggest to you that there aren't recreational fishermen in Ohio there aren't recreational fishermen in Ohio that think that commercial fishing is not a good thing in Lake Erie, but the degree to which this is being negotiated in the media and in courtrooms has just completely disappeared. And I would argue that that's because this model-based analysis, this objective quantitative analysis of the expected performance of the fishery was done in a way that relied on effective engagement. It was, I don't think, to be quite candid, that the analysis that we did that led to that sliding F policy, which was not well received, was really drastically different from the analysis that we did in an inclusive process with LEPMAG. And yet the outcome was profoundly different. And so that's why I led to this conclusion. So that's my last slide. I wanted to basically share with you this experience that I think is an object lesson for fisheries management in other places. And at this point, I would be more than happy to entertain questions if we have time to do that.
Oh, thank you so much, Mike. It sounds like that was a harborous task. And so we do have a few questions for you. Curious how you defined fish recruitment.
Fish recruitment? Mm-hmm. Well, the word is defined in many different ways in technical fisheries literature. For our purposes, we just defined it as the number of walleye that reach age 2. And we use that quantity because that's the first age at which they are available to be harvested by both commercial and recreational fishermen. That's probably the most common definition of recruitment is when the fish recruits to the fishery, when they reach an age where they are vulnerable to being harvested. But I would emphasize that that's not always the measure that's used to define recruitment.
Thank you, Mike. And then how do hatchery fish contribute to those models? Are they part of natural processes or somewhere else?
Well, for the walleye study, the case study that I talked about, there really is no hatchery program. There's no stocking of walleye into Lake Erie. It's a very healthy wild population, and there's never been any discussion, to my knowledge, of a need to supplement it. We have done similar sorts of model-based analyses of fisheries, which are much more focused on stocking, and the most obvious one would be the salmonine fishery in Lake Michigan. And in that case, the nice thing about stocking is that you know exactly how much recruitment is happening because you count them when you put them in the lake. And so it just comes into the model as a source of recruitment, but the recruitment is defined by what the truck dumps in the river or the lake or whatever.
Great, thank you. And then one more question. Is this conversation still ongoing? I know the meetings were a few years back, but I'm curious if LEPMAG is still meeting.
Yeah, well, it turned out that was part A of the story, and part B of the story was to take on yellow perch, which is also a very important recreational and commercial fishery in Lake Erie. And so from 2014 to 2018, we wrestled with Lake Erie yellow perch, which was a more challenging problem, not because the controversies were any different, but because the way they manage yellow perch is on a spatially broken down basis. There are Western Lake Erie as a different management unit and is managed independently of two management units in the Central Basin. So it was a bit more complicated. I'm trying to remember now, I think it was January of 2018, maybe 2019. The years are starting to compress together for an old guy like me. The Lake Erie Committee adopted a harvest policy for yellow perch that was informed in basically the same way that I just described to you for walleye. The members of the LEPMAG group have emphasized that they really want to continue to interact, even though we no longer have a harvest policy to develop. We've sort of fulfilled our goals, but they feel pretty strongly that the engagement that has occurred there is a good thing for the fishery and that we should continue to meet. Obviously, we haven't met since March of 2020 for the reasons that nobody's met anybody since March of 2020. But we are hoping to reconvene LEPMAG maybe even as soon as later this year.
Great. Oh, thank you so much, Mike. Really appreciate you joining us today.
My pleasure.